Hello all and welcome to this Operations Research course lecture 10 or chapter 10, more transportation problems. So in the previous chapter we saw transportation problem and its dual, and we built actually even a transsolver code that will solve the transportation problem. And in this lecture or this chapter we are looking at an extension or transportation problem called transshipment problem, and then almost a special case of transportation problem called assignment problem. But let us start with the transshipment problem here. So what is a transshipment problem? And in all its simplicity, a transshipment problem is a transportation problem with added transshipment points. So in a transshipment problem, one has to ship goods from sources to destinations. But in addition to the sources and destinations, there are these middle point, transshipment points that can be used. So one can ship the goods directly from the port to the destination or use the middle points there. And so to understand this, let's have an example. So here we have example 10.1 called, or problem 10.1 called spice with folded space. So this is like the problem 9.1 where we had the spice must flow with highliners. The difference is that now we have in addition to the sources, so here let's look at this picture here. In addition to the sources Arrakis and Tleilax and the destinations Giedi Prime, Kaitai and Kaladan, we have a warehouse here called folded space. And all these spice we can either transport them directly from sources to destinations like this, or we can use the midway point, the folded space, so that for example from Tleilax we will send some number of spice to folded space, and then from the folded space we distribute them to this Giedi Prime, Kaitai and Kaladan somehow. And yes, now this looks much more complicated than the normal transportation problem. It looks more like a network here already, so we just don't have simple sources and destinations. Instead we have these midway points or warehouses or transshipment points. But it turns out that we can consider this transshipment problem as a transportation problem. And the trick is actually very simple and very clever. The trick is to consider this folded space, so this transshipment point, or all of them if there are many of them, both as a source and a destination. It kind of makes sense because source is a point where you have only arrows going out, destination is a point where you have only arrows coming in. Well, in this yellow point you have both arrows coming in, so that's the destination side of it, and then the arrows going out, so that's the source side of it. And without further explanations, you can read it from the lecture notes, but now what we see, we will actually show how this table transforms into a transportation problem. So here's a transshipment with folded space as a transportation problem. How it's written as a transportation problem. So everything here is like before, except that we have now an additional row for folded space, so that's the source duplicate of the folded space, and we have additional column, so that's the folded space destination side. And what are the new numbers here? So these numbers 1 and 2 and these numbers 2, 3 and 2, they were given in the problem, so there's nothing new there. Then we have 0 here, which is obvious. It kind of means that transportation from the warehouse to itself, since we now have the both source and destination side, we have to understand what is the source side folded space transportation cost, the destination side folded space. But that's obviously 0 unless you want to have, well, you can transform it so to have some number there other than 0, so that number then would mean that it costs to store something in the warehouse. Why not? You can make a modification like that. And finally there is then what is the supply from folded space and what is the demand from folded space. So they are the same numbers, and this is the capacity. And if the capacities are limited, then of course this is, well, you can take it number that is big enough so that the capacity is never used. And the obvious way of choosing this number then is the total supply. Okay. So then what we have next we have 10.2, that's a solution, and in a way this is now relatively simple to build this solution, since we have already this trans solver that solves a transportation problem. Now we have managed to formulate the transshipment problem as a transportation problem according to this table. So what happens here is we simply use a trans solver. And this is relatively straightforward how this script works. I think that we have seen this kind of scripts so much before, so that I will just glance very quickly through it here. So what we have here in this folder space M that solves this problem. So we have a title block here telling what it does. Then we have a data. Okay, here is a slightly, I have split this data into two parts. So I have first have this SD and C for the original transportation problem without this folder space warehouse. So that's here. And then I have added the folder space warehouse, that's here. So what happens here I will quickly explain. So S, so supply is supply, and then appended 3. So it means that we have a supply here. So it was 1520 before, and then added 3 in the next column, sorry, next row. Same thing for supplies. Sorry, demands are demands, and then appended the 3. So it's this, or actually transpose of this. And finally C is, first we have the C, and then I add there last column 1, 2. So C before that is these 6 numbers, sorry, and I add the 1 and 2 there, and then I add a new row which is 2, 3, 2, 0, which happens here. So now this way may be unnecessarily complicated, but this way I have the data S, D, and C, including the transshipment point. Then I just solve it with trans solver, and then I have a solution here, and that's all there is to it, really. So let us little bit consider the solution. So here this X is the optimal schedule. So it's written now down here in a parenthesis. So we have the original data of the problem, and then in the parenthesis the optimal schedule. So how do you read this table? One way of reading it, for example, let's look at this Tleilax. So from Tleilax we sent 7 megatons to Kaladan, nothing to Kaitain, 10 to Giedi Prime, and actually 3 to folded space, which is the whole actual capacity. And then from folded space as a source we send nothing to Kaladan, 3 to Kaitain, so everything there is sent to Kaitain, and nothing to Giedi Prime, and nothing goes circling around there. let's have something about the destination side. So Giedi prime gets nothing from Arrakis, then from Tleilax, and nothing from folded space. And then about folded space, so where does it get its stuff? Nothing from Arrakis, 3 from Tleilax, and nothing from itself. So that was the solution of the transshipment problem by first modeling the transportation problem and then using this special transsolver function that we have. Let's look at a couple of exercises we have for this chapter or part of the chapter. So the transshipment problem. So first exercise is folded space with unlimited capacity. So you can go back to this video. I have actually given you a hint how to do this. So the thing is now that the spacing guild is expanding folded space warehouse to have unlimited capacity. So now the capacity was 3 megatons. Then we think that okay, now all the spice that ever are produced can be stored there. So how much should this improvement cost at most? So if it costs too much, there is no point of doing it. If it costs a little, then this will give a better solution for the transportation schedule or transportation cost, so it's worth of it. So this is the problem here. And then exercise 10.4, this is okay. Can you write an octave function transshipment solver that returns the optimal transshipment schedule with an optimal transshipment cost? And now what kind of transshipment problem we have? Generally with one transshipment point. So what is basically happening here? So look at the hint. If you look at the folded space.m, what happened here is pretty much written in the way that we have the original problem, and then we have one transshipment point where there's a supply and demand 3 and then route cost into the transshipment points and out of the transshipment points here, and then it's sold. So basically this exercise 10.4, what you are asked to do there is to modify the script folded space.m into a function so that it works for a general case. And again, if you understand what's going on and you are fluent in programming, as you should be at this point of the course, this is not actually that complicated. But this of course requires some programming understanding and skills. That's all for this video lecture. See you in the next one. Bye.